So before we get into the actual coding of this video, I want to show the schematic that you'll need to wire up to be able to control your stepper with the Arduino. So we have the Arduino Uno on the left here. This green part is the line driver that there's a picture of shown in the Canvas assignment, and then this is your stepper motor. The stepper motor will connect to the line driver with that white plug on it, so this plugs directly into the line driver. Then you'll need to wire the line driver to your Arduino. You'll need to wire a 5-volt wire to the line driver, a ground wire to the line driver, and then digital pin 8 to pin 4 on the line driver, pin 9 to pin 3, pin 10 to pin 2, and then pin 11 to pin 1. So this is the wiring you'll need for your stepper to be able to make it work with the code that is in this video. So the first step in controlling our stepper motor with MATLAB and Arduino IDE is to actually compile the IDE code onto our board. So the code that I have shown here is what we want to compile. You can just copy this from this video into your IDE, but I'm going to walk through what the code is doing very quickly. So the first thing we want to do is to include the stepper library. To do that, go to Sketch, include library, and then go down to stepper. It'll pop in and say include stepper.h. I'm going to delete that since I already have it there. If yours does not pop up when you go to Sketch and include library, if you don't see stepper down here, click right here on these books, search for stepper, and then right here where mine says remove, it'll say install. Install that, and you'll have the stepper library. The next thing to do is to initiate a couple variables. We're going to initiate steps per revolution as 2052. That just means our stepper takes 2052 steps to do one full revolution. We're also going to initialize rotate as 0, just to say if there's nothing going on, don't move the stepper. We'll then come down and actually tell Arduino where our stepper is. So we'll do stepper, my stepper equals stepper, steps per revolution, so the number of steps per revolution, and then the pins where we actually have our stepper. And these pins, 8, 10, 9, 11, correspond to the schematic that I showed earlier in the video. And if you have your pins different, you can just change these pins to match yours. We'll then go down into the void setup, which runs when the code begins, when the Arduino is powered up. We'll say serial begin 9600, so that's how we will communicate with a baud rate of 9600. And then we'll set our stepper speed to be a speed of 10. We'll then move down into the void loop. This loop will run endlessly as long as the Arduino is powered. So we'll say if serial available is greater than 0, that means if there's communication on the serial port. Then let's go into the loop. We'll then say rotate will be equal to whatever value we send over from MATLAB. We'll then tell our stepper to move that amount, and then after it moves, we'll set it back to 0 so it does not keep moving endlessly. So once you have this code written in Arduino, you'll want to verify it by clicking on this check mark. Arduino will run through it and compile it, not onto your board, just by itself. It'll check it for any errors. In this case, mine did not have any errors. If it had errors, it would pop up in the bottom right corner saying there was an error. In this case, there's no errors. Once we verified it, we'll want to make sure that we have our board selected. So click this drop down. In my case, I'm using a Mega. You'll be using a Uno, so it'll say Arduino Uno. So just click on that, click on Arduino Uno for you, where I'm clicking Arduino Mega. Once I have it selected, I'll hit this upload button. It'll come down here again, say it's compiling, and then it is done compiling. So now this code is uploaded to my board, and I'm now ready to go over to MATLAB and actually start talking to that code. Once you have your code uploaded to your board using Arduino IDE, you can then come over to MATLAB and develop the code I have shown here that will control your stepper. The first thing to do is to do CLC and clear. We'll then come down and clear out S, which just clears out any connections to the serial port. We'll then come and actually initialize our serial port connection. So we'll do S equals serial port on COM3 using a baud rate of 9600. In my case, my board is connected to COM3. Yours is probably connected to a different port. So to find where yours is connected, go back to Arduino IDE, click this drop down. Again, I'm using a Mega, an Arduino Mega. You're using an Uno, so it'll say Arduino Uno. Below where it says Arduino Uno, it'll say COM whatever, COM4, COM10, COM14. If you're on a Mac, it'll be a different naming scheme. It'll be something like USB modem and some numbers. It'll just be a different naming scheme. That's fine. Just get whatever it says here, go back to MATLAB, and change where I have COM3 to whatever yours says. Before I go down to the rest of the code, I have a little note as to why we're using S equals serial port rather than A equals Arduino. We don't use A equals Arduino here because if we did, we would wipe out the code that we just compiled using IDE. In this case, we're using S equals serial port to communicate directly with the code we compiled to our board. Once we have the serial port defined, we pause for 2 seconds to give the code time to actually connect to that port, so that pause has to be there. We'll then come down and say distance equals 2052. That's the number of steps per one revolution. We'll say write S, so write to the serial port. We'll send the string over, so we'll change it from an integer to a string, so integer to string. We'll change that to a string value, and then we'll send it over as a string. So we're going to send a string value of 2052 over to the Arduino board, and it'll move this number of steps. We'll pause for 5 seconds to allow the sepper to actually make that movement, and then we'll send a negative value over to the board again to have the sepper move in the opposite direction. So this will move a full rotation in one direction, and this will move a full rotation in the opposite direction. And I'll put a video of my sepper moving at the end of this so you can see how yours should look once you get this code done. Once you have your MATLAB code written and ready to go ahead and hit run. It'll connect to the serial port. Your stepper should do one full rotation in one direction, and then after it does that, it'll do one full rotation in the opposite direction.